Texan Global School. Isolating a variable. In this class, we will use properties of equalities to isolate a variable. As a review, we introduce properties of equalities. In essence, we can add or subtract any value, as long as it is done on both sides of the equality. We can also multiply or divide by any value, as long as it is done on both sides of the equality. Finally, we can square or root both sides of the equality. Let's look at the first example. In physics, it can be verified that the speed s is directly proportional to the quotient of the distance d, with the time t. We will isolate the distance d. Hence, we start by applying the multiplicative property to cancel the time t. This implies multiplying both members of the equality by t. As we can see, t over t on the right member is 1, and applying the symmetric property, we obtain that the distance d is equal to the speed s times the time t. This process can be done more simply since the time t is dividing the distance d. Hence, we can move t from dividing the right side to multiplying the left side. However, this type of shortcut can be applied to understand that steps of the properties of equalities are skipped. Now we will use the Ohm's law to practice isolating a variable in the following example. This law indicates that the voltage V is directly proportional to the product of the resistance R with the current I. We will isolate R. We will then apply the multiplicative property to cancel I. This implies multiplying both members by the multiplicative inverse of I, which is 1 over I. Hence, I over I is simplified to 1 in the right member, so the resistance R is equal to the ratio of the voltage V with the current I. For this example, we will use the formula to calculate the perimeter of a rectangle, which says that the perimeter is equal to the sum of the double of its sides. We will isolate B. We will then apply the additive property to cancel 2a, by adding the additive inverse, negative 2a on both sides of the equality. By adding the additive inverse, we see that the 2a on the right side is cancelled, hence, little by little we are isolating the variable b. Now to remove the 2 from the right side, we will multiply by its multiplicative inverse, 1 over 2 on both sides. When making the products, we see that the 2 of the right member is cancelled by isolating b. Finally, we apply the symmetric property, obtaining that b is equal to half the difference between the perimeter with the double of side a. In this following example, the electrical power P can be represented as the square of the voltage V, divided by the current I. We will isolate the voltage V. We will multiply by I, since it is the multiplicative inverse of 1 over I. In this way, I over I is 1, starting to isolate the variable. We then apply the symmetric property to prepare the variable V to be isolated on the left side. Now, since the variable V is squared, we apply the square root on both sides of the equality. In this way, we cancel the square and obtain that the voltage V is equal to the square root of the product of the power P, with the current I. For the following example, let's remember that the area of a circle is pi times radius squared. We will isolate the radius r. To isolate the variable r, we must eliminate pi from the right side. We do this by multiplying by its multiplicative inverse, 1 over pi, on both sides of the equality. Pi over pi is simplified to 1 from the right side, hence, we apply the square root on both sides to cancel the square of r. Using laws of radicals, the root is simplified, and by symmetric property, we obtain that the radius r is equivalent to the square root of the quotient of the area with pi. In this last example, we will use the law of universal gravitation enunciated by Isaac Newton. This law states that one object exerts an attractive force on another, which is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them. We will use this formula to isolate m subscript 2, which we will call m2. Analyzing the formula, we can see that we must first eliminate the denominator d squared, and then the factors g and m1. So we will apply the multiplicative law to eliminate d squared, multiplying by the multiplicative inverse d squared on both members. When applying the product, we see that d square is cancelled. We now multiply by the multiplicative inverse of g, m1, which is 1 over g, m1. When performing the products, we see that it is cancelled by isolating the variable m2. We apply the symmetric property and obtain the variable m2 isolated. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com